welcome back to the show. We got Will Tope here today with Lena Energy. Lena is really interesting because it's a different battery chemistry and has a lot of unique physics that really go back a long time. But it's coming to the forefront because we're solving a really emergent problem. Will, why don't you tell us about this challenge that brings you here to Houston?
Absolutely. So if I start with the problem that we're trying to solve, problem is today's storage technologies like lithium ion are ultimately too expensive and not the best technology to really shift long periods and large chunks of energy in and around the day. And as we're seeing more and more renewables deployed on grids, we're seeing this inability to use low cost, low carbon electrons when you need them. And that is most obvious. Human demand patterns all around the world, there's two peaks. There's one in the morning where we all wake up, we turn stuff on. Then it dips, we consolidate our use in offices and schools and all the rest of it. And then we come home and we turn the AC on, we sort our lives out. And these two peaks in the day, we need a low cost method of shifting electrons into those.
Yeah, and here we are in early September, and I'm getting these notices from ERCOT. And they're saying, please turn down the power or your AC usage from like 3 p.m. to 7 p.m. And I even saw yesterday they had this notice where they had all hands on deck. They're like, all power needs to be on call because we're worried about not being able to meet demand and they want to avoid blackouts.
Absolutely.
And it's one of these things where you go, we should have planned for this a while ago. We should have known this was coming. And every year it keeps coming back. And I think that the ERCOT folks are doing the best with what they have. What they don't have are battery storage systems.
Right. And they don't.
Yeah.
One of the issues we have is one of the best and most deployable means of renewable energy is solar, right? And that is great at eating away at the demand in the middle of the day. But we just said that's where it troughs out anyway, right? Yep. And so when you get to 3 p.m. or 4 p.m. and then by the time you get into early evening, the sun's not there, right? But that's when people most need to cool their houses down and get comfortable.
Yep.
And this is not just a Texas problem, right? This is a global problem. It's most acute in those markets where you have a ton of solar potential and a ton of heat. And that's another of the issues with our incumbent technologies is lithium ion particularly doesn't like to be in high temperatures. It really needs a lot of capital and operating expense to keep it happy in those high climates.
And so what do they do? They put air conditioning on the battery itself, or does it just...
It's typically a liquid cooling circuit.
Okay.
So it's the same kind of technology you would see in the bottom of a Model 3 or a Model Y. It's really effective, right? And that in itself will make lithium ion safe. So I'm a battery advocate first and foremost. It's really a matter of cost is by the time you've done that. And if it gets hot enough, you're going to have to do that as well as HVAC just to mitigate against the possibility of getting too hot. By the time you've done that, it's a really expensive system. And so it can do certain things really well, like frequency response and ancillary services. And that's what we're seeing a lot of the batteries today doing. But it's not cheap enough to start shifting 4, 5, 6 hours of energy in and around the day. And that's the fundamental problem.
And so that's why we need a new chemistry.
Well, or an old chemistry deployed in the right way,
yeah.
which is a good segue, I guess, to what we're doing. So Lena Energy, like we just said, is not focused on developing new chemistry sets and chasing side reactions, all of that type of stuff. What we've done is taken this wonderfully stable sodium-based chemistry that was originally developed in the 1970s and commercialized in the 1980s, and was commercialized in a way that ultimately wasn't able to get the cost down. And what we're doing is combining that original chemistry, but with advancements in ceramics, which have mostly come out of the fuel cell industry, and it's where our technical founders really built the majority of their career. And so they recognize that in the fuel cell world, when we look towards today's, most prominent fuel cells, there are all these stacked fuel cell concept, right? So it's stacks of layers on top of each other. It was taking everything that they did, and our CTO, Rich Dawson, said, well, I know a wonderful chemistry that's been held back, but we could apply these exact same principles and these exact same advancements to that chemistry and really unlock its potential. And so I've got a single battery cell in my hand here, and it doesn't look like your typical AA battery or typical lithium ion cell, right? It looks a bit like a microchip, and that's because we have this thin planar ceramic electrolyte sitting in there, and that's where we get our safety from. And that's also because we can churn these things out on an automated manufacturing line. That's where we get the cost down as well.
Yeah, and just for size, a big circuit chip or a small coaster.
There we go.
And describe it.
Yeah. We are a deep tech company, so we've been at this now for in earnest about 4 years, and we are still looking towards making bigger cells in the future. But we're in a place now we're able to go demonstrate the product. And so that's a real key milestone for us. Last year, we did our first systems, right? So it wasn't just about what an individual cell could do, but we were able to demonstrate what a collection of cells together can do as a product, right?
Got it. And so, and this will show how little I may know about batteries. So there are different battery form factors, right? There's
That's
like prismatic cells, there are coin cells. This is a non-standard form factor.
It is. It
right?
is.
And that's the. Tell me about that.
So the closest thing to it is a prismatic cell, but really it's its own thing. So we have inside here on one side, we have our cathode electrode. We then have that thin electrolyte, that ceramic electrolyte, and a means of creating an interface between the two. And on the other side, we have a metal anode. So we have a sodium metal anode. And that's because we're using a sodium metal anode, that's a really high energy density in terms of you've got a lot of electrical potential in a small amount of space and weight. And that's how we get what a key metric for batteries is energy density. And that's how we're able to achieve high energy densities. But one point of note there, energy density is typically really interesting for EVs.
Yeah.
And that's because higher energy density equals more range.
Yep.
It's less critical to energy storage in terms of you typically have a lot of space and you're not worried about weight. But if you get the energy density up of a battery, it means you have less cells per kilowatt hour, right? Or less cells per megawatt hour. And that's how you get the cost down.
Yep.
And if you look at the majority of the cost reduction we've seen in lithium ion over the past 5 years, it's all come from energy density developments as opposed to manufacturing improvements. The majority has come from that energy density.
I remember when we were doing engine systems, we would often get quotes based on volume or weight. And it was plus or minus 15%, but it was always amazing to me how at the end of the day, it's kind of the same.
There we go.
Cost.
Yeah.
And it's that same thing. It's about energy density. It drives a lot of the other system factors.
Absolutely. Yeah.
So I totally relate to that. And so there are other changes to the system here that result from the novel chemistry. And one of the things I think we talked about was this chemistry has better heat performance. Tell us a little bit what drives that.
Yeah, we took a look at energy storage systems, and I mentioned that lithium ion, one of the issues it has is that it doesn't like to operate in high temperatures, and that's because the ideal operating temperature range for an individual cell is between 23 degrees and 27 degrees.
Oh, I didn't know that. Okay.
Yeah, so that's ideal sweet spot, right? And so you're using a lot of energy to try and get as close to that sweet spot as possible. And that means wasted heat, right? You're using that liquid cooling circuit can't do much with the heat when you're cooling something down from, say, an ambient of 30 degrees to 25 degrees. The other thing that happens on almost every electrochemical device is when you cycle it, you generate heat.
Yeah.
Right. And from the start, our engineers knew that there must be a better way of using the heat that you generate from cycling to your benefit, as opposed to having to engineer systems to remove it.
Yeah.
And so, great thing about this chemistry is it has a really wide operating temperature range, and it has a high operating temperature range. So I'm going to use Celsius, lean into my Europeanness here, but it operates between, at the extremes, 160 degrees and 300 degrees. We like to operate between 220 and 300 with a set point of 250. But every time, so we heat the systems up, and every time it cycles, it's generating heat. And so we just wrap our systems in passive insulation. We get rid of the moving parts, we get rid of the liquid cooling system, we get rid of the HVAC. And we've designed the system so that we're generating as much heat as we're cycling as we're losing through the natural heat losses of the system. And it was a really big milestone for us to actually demonstrate that. It'd always been a principle, right? But I think you explain that and people are like, okay, it sounds like it might make sense. But we were able to demonstrate that thermal performance in a distribution scale system and show that the heat losses are relatively small, and the math does make sense. The science pans out. We can hit these plus 90% round trip efficiencies by getting rid of all this additional thermal management system.
Yeah. And it's the system design that really drives things. And I think one of the things you were sharing with me earlier is just on a dollar per dollar basis, there's a performance improvement at the cell level and at the system level. So share a little bit of that.
Yeah. So right now, if you just looked at the global benchmarking for energy storage systems, a full turnkey system per Bloomberg is $322 per kilowatt hour. In reality, that's turnkey, right? So that's a shipping container filled with cells, with everything from the cells, the housing, the thermal management that we've talked about, the power conversion, the shipping container itself. It's plug and play with some EPC money on there.
Does that include people making money?
There is a little bit there, but
okay, yeah.
If we look at our system, primarily driven by the raw materials, but also that simplified balance of plant, we're benchmarking at scale. We will deliver systems at around $185 per kilowatt hour. So a nice disruptible space there. And the other part that's interesting for our business is those systems that we're talking about are coming out of gigafactories, right? This concept of a factory that's producing over a gigawatt hour per year of cells. These things are huge, right? If you've seen the Arizona one, the Tesla Arizona, these are colossal facilities, multi-billion-dollar facilities. One of the benefits of going at this problem from the chemistry and from the bill of materials is scale is not your only lever. And so our strategy is based around the fact that we can hit those competitive price points at a much smaller scale. And then, of course, we can grow and get even better and better and better. But we can do it with, a 100 megawatt hour per year facility. So a mega factory instead of a gigafactory. And at least as a startup, especially in deep tech, that for me is super powerful because it means profitability is within arm's reach, despite this being a really important deep tech solution.
And one of the things people talk about is finance risk. And
exactly.
You don't have to raise $1 billion to get going. You can really reduce a lot of the risk for the investors. But kind of going back to the problem, right?
Yep.
Economics means lower cost, total installed cost. And that kind of dictates the useful, economics of the battery system. But what about operating life? Is that also comparable? I think the numbers we're seeing today are like, 10,000 cycles? Or am I off by an order of magnitude?
No, you're not off by an order of magnitude. And it's a constant discussion point in industry, right? Things you generally need to look at is the depth of discharge that you're measuring your life at, the life cycle itself in itself, right? So there'll be a number of cycles, and then what is the state of health of the battery at the end of those cycles? So we're somewhat comparable with a chemistry called LFP, lithium iron phosphate, which is the emerging technology and or the emerging best in class for energy storage. And that means this chemistry has been demonstrated to and warranted to 4,500 cycles down to an 80% state of health.
Okay.
So we're really happy with that. You can go further. We've seen others use this chemistry back in the day to 7,000 cycles. But it's for anyone out there looking at energy storage system economics, I think it's one of the most important parts of the equation. And it's one where you need to make sure you're comparing apples to apples and oranges to oranges, right?
And I guess as a practical matter, this is when they talk about a cycle, it's a full discharge, and 4,500 discharges is already 12 years, roughly, if I do bad math.
One cycle a day, right? And again, the standard is generally quoting the health down to 80%. Ultimately, the industry doesn't really know what we're going to do here, right? Industry is investing in these projects on a 10 or 15 or 20-year basis, right? The reality is it'll come down to a cost-benefit analysis. In 10 years' time, say you've lost 20% of the capacity of the battery, it'll come down to a question of, has the cost of battery cells gone down significantly enough that it's worth refreshing the cells, right? And getting back to 100% capacity. So I've got, at that point, I'll have more revenue generating potential because I'll have my full cycles back. Or should I just wait it out and basically accept that I'm not discharging as deep as I used to be able to?
So the economics are superior in terms of cost, and you got similar life cycle performance. Where are you in the commercialization cycle? And the real question is, why aren't people buying it off the shelves?
So it's the same answer to both of them. We are a deep tech company that is still developing our technology. I mentioned we've done systems, right? But we're still building our systems out of the lab, and there's still things we'd like to do to improve the performance. In terms of that commercialization journey, then it means rather than putting these on the shelves and having them ready to sell, we'll get there, but we're not there yet. It came down to, within the sector, right, we need to find where can we be most impactful. And for us, that was taking one of the elements which is unique here is that we talked about how inside our systems we're operating at 250 degrees. And that means from a efficiency perspective, it doesn't really matter if outside of the system it's 20 degrees or 40 degrees or 50 degrees or even 60 degrees. Whereas in a typical system where you're trying to cool those cells as best as you can, efficiency drops off a cliff as you start to get into those high temperatures, and it becomes a safety risk as well.
Yeah.
You can keep it safe, but again, it adds to the cost to make sure you're not getting anywhere close to thermal runaway. And so we looked at that problem and we said the problem is most apparent where you've got high solar potential, right? And so we looked at some of the emerging markets like India, where massive amount of solar potential in the middle of the day, also very hot, a growing middle class that wants to turn on air conditioning, and that duck curve just getting steeper and steeper and steeper and steeper. And so that's where we've done a lot of our work out there, and we've got some great relationships and partnerships in place to go demonstrate and pilot project our systems at a distribution scale by the end of this year. And then from there, we'll be growing in line with our manufacturing capacity. So as we step up production out of Lancaster, where we're moving out of glove boxes and into automated manufacturing, we'll be able to get more and more of those systems out. But great to have our hypothesis validated in a market like India, which for me, I go out there and I'm just amazed by the amount of growth and potential.
Yeah. So I don't know anything about the power market in India. So obviously here you have like a deregulated market in Texas. We have generators. The ERCOT system has a way to compensate people for energy. Is the Indian market like different? Is there a different buyer? I assume the regulator is different.
So here, one of the earliest customers for an energy storage system might be a trader, right? A power trader, right? It's just another means of capturing arbitrage.
Yep.
Exactly. In India, that's not going to be the case. But what you do have is a power producer who's also typically acting as a distribution company as well. And they're sitting on the same problem, which is, okay, I've deployed a bunch of solar on a bunch of rooftops, right? And I've got plenty of that in the middle of the day. But my customers are experiencing blackouts, and I'm having to pay a very high price to turn up my coal. And it's about 80 to 90% coal mix out there still. In the afternoon. And so if I can deploy a storage technology that can take as much of that solar in the middle of the day and shift it, I'm saving electrons and I'm saving carbon. Sorry, I'm saving money and I'm saving carbon. And so it's almost the customer is less of an independent third party who's just capturing arbitrage. It is the supply chain itself. It's the generator and the transmitter and the distribution side of the equation. And that exists at distribution scale, which is where we're targeting initially. But the same problem exists if you're trying to do large industrial customers, right? They ultimately will want to load shift and eventually good services as well, right? So stacking instead of being directly attached to the solar, you're just importing from the grid in the middle of the day to try and make that back available later on.
No, and I'm curious about India as a market, just because I don't know much about it, and I'm thinking, even in the U.S., we have a challenge where utilities sometimes aren't incentivized with their own structures to want to adopt new technology like this because they have these ratepayer cases, and there's just no way to recognize the value. Is there a mechanism in the Indian market that's forcing utility to have to adopt this, or is it someone gets in trouble if?
There's two sides of it. There's incentives that have just been recently announced over the past week for those deploying energy storage technologies, project-based incentives, right? So this is basically to de-risk. If you're deploying a storage in a certain duration for the first time, it's untested, and these project incentives will de-risk it sufficiently that you're willing to deploy the capital on them. The other side of the equation is production-linked incentives. So there's a ton of capital and incentives from the government to build manufacturing out in India as well, because we look at, again, a lot of people in this space are chasing building battery gigafactories. So that's not unique to India, but there's certainly what may be unique there is they've got specific incentives for what they call advanced chemistries, and that's alternatives to lithium ion. It's alternatives to the incumbent. So there's a discrete fund just for these advanced chemistries.
Yeah, and I think just on a completely separate topic, I think some of the news that came out over the summer was that there's an expectation that the demographics in China and India are changing, where it used to be expected that China would be the world's largest economy, and now there's an assumption that might actually be India, because the way the economics have been developing are different. And so there's this kind of rising tide where it makes sense that you'd want to be in that market long term, right?
And even if you are just a climate activist. Activist is maybe the wrong word, but if you're passionate about climate change and you're passionate about clean tech, if you just look at on population alone, what India does matters.
Yes, exactly.
Right.
Yes.
Yep. So whether you're there or not, what India ultimately decides to do is really important. And G20 is there this year, and that just makes it so clear that is the case. There's going to be a lot of buildings built out there. There's going to be a lot of new vehicles on the road out there. There's going to be an incredible amount of generation and renewable generation deployed. But in this case, rather than say in the UK where we're based or a lot of the US, it's not retrofitting renewables into an existing grid. They're growing in real time, right? And that again comes back to the need to actually be able to shift large amounts of energy and make those resources more adequate.
Yeah. Well, this is a show about Houston, so we're going to bring it back.
Yep.
So you're actually in Houston this week.
Yeah, I've a few other meetings, but Houston has this magnetism, right?
Yeah.
You just always seem to come back here. But we've got several friends and partnerships here. Our first interaction in Houston was with the Rice Clean Energy Accelerator Program. So we were part of Class 2 of that program. Loved it. I recommend it if you're a startup, clean tech startup. They run a great program. A really good set of mentors and insight, and really great connections to the investment ecosystem here. Off the back of that, we then started talking with Halliburton Labs. And so we looked at that program. It's different from the Clean Energy Accelerator. It's what they call a scalerator. It's a much longer term program. Right? And it's not just a marketing principle there. It's very much an accelerator. You basically show up and do what you're told, and by the end of it, you're better for it, right? But there's enough program there that you just need to jump through all the hoops, and it's almost like summer camp. And now on the scalerator, you go to Halliburton Labs, and there's all sorts of stuff they can provide, whether it be physical facilities, right? Do you need a footprint space to grow out of? Do you want mentoring when it comes to strategic scale up in terms of flow diagrams and strategic objectives? What should you be solving for? How quickly should you be growing? X, Y, and Z. And then on the engineering side, they have a huge group of industrial engineers, right, who can look at a product and look at it through the lens of high manufacturing and throughput, as opposed to a lot of us in this early stage startup space. We're looking to get things that work, as opposed to that we can churn thousands out all the time. And so with Halliburton Labs, we took a view to understand all of this, and then applied to be a part of the program, understanding what we thought we could get out of it, and lucky enough to join that program earlier this year. So we have a consistent back and forth relationship with them to make sure we're both using each other as best as we can, and we're accelerating our growth as much as we can with their support and their investment.
Yeah, no, they've been impressively very startup friendly, and I think at one point they were telling me one of their goals is to create kind of moments for the startups where they can really point to how things changed for their business, and they really flipped over in terms of creating that scalability.
Yeah,
and I think it's a mindset that points to how an organization can really support the startup growth cycle. And it's a nuanced distinction that you point out. Like an accelerator, early stage, it's prescriptive, it's programmatic. You need to follow the process. The goal at the end is to like raise money.
Right.
All right. And a scalerator is a different position where you're trying to say, where's that inflection point where we can reduce cost and manage scale. Right?
Exactly.
So it's you need all of those in the life cycle of growing a company.
Yeah. And for us, it was very much sooner rather than later understanding where our bench strength was as a company, right? And whilst we have manufacturing knowledge, it's not our core bench strength, and we recognize that. And that's where before you realize that within a pilot line, it's best to realize that early on and onshore that expertise. So Halliburton Labs was one way we did it. We've also brought in advisors, but I think being aware of what you do well and what you need help with is key, and a bit of humility can go a long way. And we've certainly found that just being open and receptive to their support and bringing that into us, and then embedding that into our DNA going forward, has been key. Yeah, no, every dollar is so valuable at a startup. You don't need to invest in things where
you can kind of borrow or rent that expertise somewhere else.
Absolutely, yeah.
So it really helps. It's a force multiplier to have a partner like that, for sure. But you're also here in Houston to get in front of customers and partners, right?
Yeah, absolutely. So, that fundamental problem we just talked about, ERCOT, exists here as well.
Yep.
And so this is a global market, and always working with various people on developing pilot projects and developing those long-term relationships, as well as looking to the future about potential of scaling here as well, right? Our ambitions are high, right? And as we look forward, we have the potential to deploy all around the world, and that means we're going to need more and more manufacturing all around the world. We're starting out with the UK, but ultimately our plan is, once we've demonstrated that profitable manufacturing, we'll be able to cookie cutter that recipe in all sorts of places.
Maybe there's a mega factory on the street in my future.
Yeah, absolutely. I wouldn't say never. Wouldn't say never.
Yeah, but we got to get there first.
So,
you got to get sales there first. and you were sharing with me earlier, one of the things you appreciated about working with the Banerjee industry is their long time horizons.
Yes.
Yeah. So share that with me.
So we've committed resource here to come and attend events like Venture Houston Day to Day, and being part of Energy Tech Venture Forum last year, and all of these things. And one of the reasons we've done that is that I worked in oil and gas previously, and recognized, yes, within that DNA is a very long time horizon. They look at things through a long lens, and they're not just looking at the 1 or 2 or 3 years in front of them. The other part of the equation is they're also extremely technology focused, right? The oil and gas industry, whilst it may be slow to adopt technologies, if you were to be critical of it, technology has made the industry what it is today. Whether you look at unconventional space, whether you look at horizontal drilling, all these various pieces are technological marvels. And so bringing those two things together, those two attributes and those two pieces of culture are really compatible with an investment thesis in deep tech and climate tech, because these things do take time, right? This is not the same investment opportunity as software, and that is a matter of fact, right?
Yep.
But at the same time, if you're passionate about clean tech and the climate, you're not going to solve this problem with software alone. You're going to need to have hardware, and in fact, hardware is going to have the most impact in the long term in terms of tons of CO2 mitigated per dollar invested. I truly believe that.
Yeah.
And so there's those combinations of two things where we've seen that DNA seep into the investment community here, the emerging investment community, and we really liked what we saw there. And the other piece then is working with the incumbent energy industry, right, which I am a big supporter of. Their CVCs, there's no better place to be than here if you want to interact with the corporate venture capital groups of the energy majors. And so that's another opportunity that we really like here. And Halliburton Labs, to a certain extent, it's evidence of that, right? We've seen what we thought validated through our interactions with them.
Yeah. And that's a big piece of the conference today, literally, is a lot of CVC participation, a lot of engagement. And for those who've never been to this conference, a lot of the CVCs end up presenting to each other about kind of their best practices and learnings. And so it's kind of shows how the corporate investment culture here tries to learn from itself and progress forward in its investment energy. So I think it's a unique to Houston kind of conference. It's a good show. Honestly, the Rice folks run one of the best conferences that I've been to. I don't know if you've probably gone through the investor speed dating, probably once or twice. I'm always impressed how they pull that off. It's efficient. You get it done. You meet 15 investors, and you're like, oh man, I wish I could do this at every conference.
Yeah.
You know?
And if you can't figure out whether you're a good fit or not in 10 minutes, you're doing something wrong. So it's quite nice just to like you say, get through a lot of interactions. They ran a Capital Connect event on campus yesterday as well, which I was at, and they did a great job.
Okay, that must be new since I did it, so I got to figure out what that's about. But no, they've been doing it for well over a decade. So they're really experts at putting on this really efficient program. So would recommend it to any founder who wants to raise capital in Houston. You got to go through this program, and it's a good reason for you to be here. I wanted to dovetail a little bit into your own background coming from energy. I think you said you were at Exxon before, but tell us about where you started.
Yes, so I'm a chemical engineer, and out of university, actually during university, I started interning with ExxonMobil in the UK. But I came out of university and joined ExxonMobil. At first, I was an engineer, but I only lasted a year down in a refinery, and they quickly moved me out of the technical side of the business and into the commercial side of the business, where I was focused on a variety of business development roles down in London, in Scotland, in Aberdeen, and here in Houston, working on the Permian. The relevant point of that career, I think, for today's discussion and Lena is at the end of 2019, early 2020, I joined their trading group as they were building out a trading group. And part of that, I was the bag carrier there. So on my LinkedIn, it says chief of staff, but I was the bag carrier.
Okay.
And looking at power markets, emerging power markets, what were going to be the asset classes to invest in today that will be able to monetize on the volatility of tomorrow. And batteries and energy storage is one of those asset classes. So I got naturally curious and started working in this space very early doors when there wasn't much deployment. But even then, what struck out to me was just this huge amount of disruption potential and the fact that we were building shipping containers and filling them with the exact same cells that we were putting into roadsters that could accelerate like nothing else, right? And a high performance battery. We're trying to use that for the same thing on energy storage when they have two very different use cases.
Yeah.
The huge amount of tech disruption to say there must be a better way to right size the solution to this problem. And then the second piece I observed as we started looking at people developing these projects was the supply chain just fall apart because you had that multifaceted demand, because you had a small set of critical raw materials that is getting pulled by heritage consumer electronics, getting pulled by EVs that were just really hitting their inflection point for adoption. And then this growing need for energy storage, it just put too much pressure on it, right? And prices went higher. And we've seen that now. We've seen this year versus last year, prices went up for lithium. And that's not what we saw in solar, which is what everyone was expecting this cost curve to do. And we've seen lead times on these things go through the roof. If you order a mega pack from Tesla today, it's like a 24-month lead time or something like that, right?
Yeah.
And so, having seen all of that, I said, I'm pretty passionate that there's an opportunity here. And I started then looking at what were the emerging technologies that could fill that role, and learned about Lena Energy, who at that point, it was the technical founders had brought it through to proof of concept. But it was really great timing because they were looking at, okay, should we put these cells into cars or should we put them into, mobility applications or whatever? And I was coming in it from this is the perfect technology to optimize and only optimize for energy storage, right? Try to get the cost as low as you can by focusing on the performance metric that energy storage needs. And so since then, I kind of say my overarching role at Lena is to make sure we're focused on that problem and not the solution anymore.
Yeah. No, I think it's an astute observation to think about the supply chain and think about where you kind of sit in the value chain. Because at the end of the day, mobility must have that kind of energy density, and they will pay a premium for it.
Exactly.
And, even the most expensive lithium-ion batteries end up probably being in your iPhone, because that needs to be the most mobile and most controlled and most safe. And energy storage only cares about kind of that longer duration energy, not power density, but energy density. And so you kind of you end up being a little bit more of a price taker, and that kind of it is one way to think about it.
It's one way to think about it. There's a spectrum in terms of what duration you need and what performance metrics you need, depending on what you want to do with it. Right. Today, if I look at what a battery is doing, most of the investment is going into batteries which are providing ancillary services and specifically frequency response. And that we could have a whole discussion about what that is and why. Exactly, right? But ultimately, what that means is they're sitting on standby and they're injecting and they're consuming large amounts of power in a very short amount of time. And by doing so, they're keeping the frequency in check, despite the fact that we're losing inertia off the grid, right? As we're retiring heritage spin-based generation. Technically, you don't need a battery more than an hour long to be able to do that, right? Because you're sitting on standby and it's pretty reciprocal. So as many times as you're pulling power, you're pushing power in a few minutes later. As we look beyond that 1 hour, and by the way, lithium-ion, perfect technology for
that.
We then get into a space between 1 hour and 4 hours where a couple of performance criteria come in, a couple of priorities come in, but you're seeing more trading. First is real-time trading. So most markets around the world will have gate closure and then real-time balancing, where power is never produced as you expect it to be, right? But it has to be perfectly balanced. And so there's this real-time minute market where people are trading power back and forth, and batteries are really well placed there, right? Because they can, if someone's ended up long, they can take that in and get paid sometimes to charge. Then you look beyond that, and rather than real-time trading, you start looking at block trading and day-ahead trading and, screen arbitrage. So that's probably the gap between 2 and 4 hours. But all through that, lithium ion is best in class right now. It will be tough to disrupt because they've got years and years of benefit behind them and scale behind them. What we're looking at is that next phase now, what I'd call medium duration, which is between 4 and 8 hours, and it goes back to the duck curve and 2 peaks in the day. Ideally, you want to take the solar in the middle of the day and shift it to the afternoon, which we talked a lot about. But if you want the most out of your battery, you should also be charging on base load overnight and discharging that into that morning peak. And so 4 to 8 hours, medium duration, is really about load shifting. And that's where cost is now really important. You can stack those ancillary services, but you just need to get the cost really, really low to make that economic. The next stage after that is probably 8 to 16 hours or 24 hours. And that's a diurnal kind of 1 cycle a day battery, which you can do a variety of things. You can have a completely off-grid yourself with solar, right? So you can convert that solar into ready, available when you need it. Or you can blockify your solar and sell it as a PPA, and sell it as a ratable PPA instead of as produced, which typically has a pretty big discount these days. And so the final step, which is emerging, it's new, is 100 people are out there making 100-hour, 150-hour batteries that are trying to be a holistic alternative to a coal plant. So it's enough storage there that if you connect it, it will be able to weather any sort of outage, combination of solar, wind, and importantly, wind, right? Wind can be gone for several days. And so these 150 hours, it's almost the last step you need if you wanted to completely renewabilize. That's a word I just made up, a grid. And so that last piece is where cost is even more important, right? At that point, you're talking a megawatt per acre. So you just need to get it really, 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 really cheap. So I do think in this spectrum, and it's a little bit like cars, right? And mobility, you're probably going to have a different battery in your two-wheeler versus your city car versus your high-performance car. You're going to see a technology spectrum evolve over time. We've kind of fallen in love with lithium. We fell into that relationship. I'm glad we did because it's unlocked a ton of potential. But we're now starting to see the strains of that relationship as we're using it for everything and anything.
No, it's I could see how you were in a position to understand that and appreciate that different needs and different prioritization. And the duck curve is the one that we're focused on most today. The as you were talking about the diurnal need to shift power. I have solar and battery on my house, and there are days where it's just the sun isn't shining enough, and I'm like, well, I'm glad I have grid backup, and I don't have to be fully independent because I would have been out of power by 10 a.m.
Island yourself, right?
Yeah, exactly.
Not to go off too much of a tangent, but recently got a Model 3. And one of the other interesting things you can do at a residential scale is they have a scheme out there where I tell the grid at what time I need my battery charged. 7 a.m. is what I tell them. And they'll charge it when they want. Right. And so that's another way of dealing with, that's more of a frequency, not frequency response, but it's more of a hour by hour issue. But when my service provider, my utility is long power, they just send it to my car instead of having to turn down or incentivize someone to switch off. So we're seeing a ton of interesting stuff happen as we integrate storage, combine it with new demand side response software and intuitive algorithms to know when we're going to use energy. I think it's a huge space that we don't participate much in ourselves. I look at it as a fan and a geek rather than from a Lena perspective. But it's fascinating just in the last few years how different that ecosystem now looks, right? And how much control can now be put on the demand side as opposed to the supply side, how much you can do on that side.
No, I remember, was it 5 or 6 years ago? It was a concept paper that people would do that. And now it was a question of who would actually do it. Would there be a startup facilitating it? But really, it's the utilities who said no. We need the ability to put that long power somewhere, which I think is brilliant, and it's good, and
it's
we need
good.
it. So that's fantastic to hear. When you think about kind of the moving the business forward, tell me about some roadblocks you guys might have experienced in the last year, and how did you overcome them?
Yeah, the most common roadblock is that you never have enough resource coming from ExxonMobil, right? Which you have a ton of resource behind you. It can take some time to get to the point where you've decided to do something, but I never felt that constrained when you had the world behind you at ExxonMobil. In a startup, you never have enough money, you never have enough people, and you never have enough time. Right? I mean, it's just a constant stream. I think if I look to the biggest roadblocks, one is having the conviction early on to believe in your product market fit.
Yeah,
right? It takes quite a bit of it's a combination of humility and confidence, which is quite a juxtaposition, right? But you need to be confident enough to say, this is where the tech is going to make the most difference, and humble enough to, when someone says, yeah, but could you put it in cars because that's a huge market, be like, I could, but it's really not what we should be doing.
That's
right?
a conviction.
It's the conviction, and I think going through that, in hindsight, you always wish you'd got there much quicker, right? I think, but it's so important for a startup to find where they can make the most impact and then lean in, and almost the nicher your beachhead market, something I've found, the better.
Yeah.
Because when you find those customers who are really, really stranded, who don't have an alternative, who really need your technology, and there may be less of them who are the most acute at that pain point. There may be less of them, but they are going to be willing to grow with you, right? Because your technology is so important to their long-term vision. So I think getting to that place as soon as possible is something I would say is we're glad we're there, right? But it's something to, being humble, something that I always wish we had got there sooner, right? And not be afraid to go real niche.
Well, and I love to ask this question of entrepreneurs. How did you know that you had product market fit? What was the feeling where you said, this is it?
For the ultimate validation was when you had large strategic big companies, right? Who really don't have much reason to engage with early stage startups until you're ready to sell them 10 megawatts or 20 megawatts. In India, it was when we were seeing traction with those large, tier one organizations and having them ready to sign agreements. That was when I thought, okay, we suspected it, but now this is the proof that we really have found a spot that needs our tech. Earlier on that, I think, it's funny, we talk about the temperature, and from the start, we've always said that the fact that we operate at high temperatures is great, right? We're doing that because we know we can then use heat to our advantage, and we can get these high round trip efficiencies. But early days, some people don't like that, right? It's a bit abrasive because when you think of a battery, you think of something like an AA, or you think of your laptop, and it defies belief to think that could be a high temperature. Whereas again, when we started talking to customers, they say, we're operating at high temperature, and they almost finish the sentence for you. They're like, oh, because then you don't have to worry about cooling, right? Oh, there you can operate in high temperatures, right? And they know that problem so well that they lean in, connect the dots, right? And so again, it was another example of, okay, you really need to lean in on what you're doing well, and be proud and push that to the front of your agenda.
Yeah, no, I think that was also a good comment when you said, these big companies, these tier one companies are kind of break the mold and need to talk to you and are willing to get to agreements when they usually wouldn't pay attention to a company that's less than, I don't know, 100 million in revenue. That's when they've looked everywhere else.
Yes.
Right. And
which doesn't feel great.
Well, that's part of the matchmaking.
But that's
process.
The humility as well, right? That's it's being okay with the fact that the battery space is quite renowned, unfortunately, for a lot of people at a very early stage making very grandiose claims. And I think instead of going out and putting a piece of paper to say, I'm going to go from current state, maybe seed stage, to I'm going to have 20 gigawatt hours and I'm going to have X% of the lithium ion market by 2025, right? That's not something anyone can really believe in from my perspective, right? I think it can go back to humility. It's like I've found this pocket of the ecosystem where lithium ion is just not reaching, right, for multiple reasons. And I'm sure there's other companies like us that, and you look at the landscape, and we talked about different durations, there's all sorts of other metrics that's going to divide the performance priorities of customers. There's other sections all around here where new chemistries are coming into play, right? And it's from those seeds of beachhead customers, then we'll see this growth of a variety of different technologies. And for sure, I believe that we're going to see a diverse battery mix in the future, right? We're not going to see a one size fits all. We are going to see a diverse set of solutions meeting a diverse set of problems.
Yeah. Oh, that's fantastic. Let's see. I want to go back a little bit to Houston because we're running a little low on time. We talk about why you're here in Halliburton Labs. And I think you've been here over 3 years now, or 2 years. 2 years. We've been coming back and forth.
Yeah, about 2 years.
Tell me about what's changed in the last 2 years, because you especially get to jump in and see things kind of evolve.
Yeah, it's a good question. I think there's a lot that hasn't changed, which is the good parts of Texas. I gotta say, it's always nice to come here. People are so nice, right? People talk to each other, right? And that's true where we are in the north of England, which is more true. But versus say London, where I've spent a bunch of my time, it's quite nice to have a bunch of friendly faces. I think what I've seen change most significantly is in and around the approach to clean tech and the approach to climate, especially from the large companies. One thing for me which cemented the conviction of the energy majors was when we started switching to science-based targets. Because one thing I've always seen, and if I think back to my time in the industry, once you set a plan and budget to things, we knew how to steward that, and we knew how to make sure we were on time and on budget. And rather than taking climate tech and clean tech as an additional loose strategic priority, which it could have been accused of, I'm not accusing them of it, but it was open to that level of criticism. Once you converted that into, okay, we're going to hit X, Y, and Z by this year, I think we started to see a lot more motivation to now deploy existing technologies. We're seeing more and more folks deploy renewables within their portfolio, right? There's a spectrum of who's doing more, who's doing less. But we're also seeing that seep into the CVCs, right? Because the CVCs are now getting a direct pulse check for what the business line needs in order to hit these science-based targets. And so they're out and they're shopping, right? And they're shopping within a pretty tightly defined thesis now of what they want. And luckily, energy storage is on the top of the list for a lot of them, right?
No, it's that old adage, right? What gets measured gets managed, and the science gives you a way to measure it objectively. Right. I'm curious because you do come from a more European perspective. I think we obviously see a new CEO at Shell who's kind of pulling the pendulum back a little bit, and I think we're seeing it with some of the other European energy companies. Is that something you guys are feeling over there, or is it more just a water cooler talk?
That's a tough question. Yeah, it's a good question. So let me just give my personal opinion on this, right? My personal opinion on it is that we did see energy security, not just the carbon intensity of our energy, but energy security over the last couple of years, for obvious reasons, with everything going on in Ukraine, come into the equation, right? And I think that's a big driver behind the fact that we need a mix of secure but also long-term clean sources of energy. And that's probably driven some of the shakeup. I think the other thing, just speaking completely candidly, is that oil and gas made a ton of money. Right?
Yes.
And these are publicly listed companies. And at the end of the day, you're going to want to reinvest the money you make in a means of making more money, right? And when you have such a step change, if you go from COVID, negative oil, right? I was in Houston when we saw negatively priced oil to $110 a barrel a day, and that's where the majority of your revenue is coming from. It's no surprise that something shifted, right? From a strategy perspective, right? You have to adapt and change. But I do think long term, the strategic priorities remain, which is bring in safe, secure, and reliable and low carbon energy into the mix, right? And the best part about that is the low carbon energy is the cheapest as well, right? Once you've got it deployed, is the cheapest.
I think that's one of the things that we don't feel as much here in Houston is the energy security aspect. Um, Energy always needs to be reliable and always
Yeah.
needs to be on, but just the the events in Ukraine really drive that conversation in a way where, in the US we're a net energy exporter now.
Yeah. Now,
Take it back 15 years ago, the conversation was all about how do we have energy security here. And so I can understand how that really shifts the way people think.
yeah.
Thanks for bringing it here to share with us.
But I think
yeah,
on
yeah.
reliability is another
Yeah.
thing, though, right?
Yeah.
Because that's the other important role that specifically energy storage, but also renewables plays.
Yeah.
I was here during the big freeze of 2020, right?
Yeah,
Was it?
yeah.
It started
Yuri,
2020.
yeah.
And we just had a small kid, and I remember my
Mm.
wife being frustrated by the fact that we had power cuts in the middle of the summer because it was too hot. And then we got a big freeze, and we got power cuts, and we've got all this, gas infrastructure. And on the surface of things, let's be honest, it's pretty jarring to be in the energy capital of the world with all this incredible wealth of gas resource and sit there and have a grid that is super constrained and it's struggling and it's on the verge of collapse, right? And I think that was a wake-up call as well for industry, which is, okay, you need a diverse mix and a robust mix here, right? For me, that came around the time when I was formulating this thesis, which was, we're going to need cheaper energy storage so it actually gets deployed on these grids, right? And it's not just a pet project.
Yeah. No, and to be honest, that was the experience we had where we decided we're going to get solar and a battery.
Yeah.
Just so we could ride through the 6 hours we don't have power.
Yeah.
But also to protect against the future challenges if there were any. And luckily we had the means and the ability to finance.
Yes.
Which not everyone does, which is why you need to have cheaper power. But going back to the Houston ecosystem, are there other changes you've seen? So you've seen the CVCs have changed. What about the the support parts of the ecosystem?
I mean, I'm not sure I can say that I've seen a shift, but I can certainly say that you yourself attested to how well Venture Houston is put on, right? I think the same thing with Energy Tech Venture Forum. There's a ton of support here across. You've got startups and a real maybe that thinking out loud.
Yeah.
Maybe that's one of the observations. Is just if I go to the Ion or I go to Greentown Labs, there's always another hardware deep tech startup that I didn't know before who's popped up since the last visit, right? So we it seems here in Houston, people are not afraid about deep tech, and I love that, right? Because someone's got to do it.
Yeah.
Someone's got to bring this hardware in.
Yeah.
So that's great. But then on the other side, I think just across startups, then you've got the service providers and support ecosystem, like places like the Ion, like Greentown Labs. You've got the investors themselves, and then you've got the big corporates. All of those are represented at these events and well represented. And then you've got more and more students as well coming. So at the event today, look at the name badges, there's a ton of students out there as well.
Good.
And they're seeing this live, right? And that's the pipeline of talent that is going to need to feed all of these different places. So it's a bit of a weak answer, but I'll just say I think I was pleasantly surprised, given, I lived back here, going back to 2000.
Yeah.
Pleasantly surprised to see the amount of energy and enthusiasm for clean tech and for climate tech.
So maybe this next question, it's not really limited to innovation, but just given you've been here so long in the past, what's a hidden gem about Houston that people should consider when they think about, should I move my business here?
So let me just think about it. The obvious one, which is not a hidden gem because I think everyone knows it, is the food.
Yes.
Right? But you probably get that answer all the time.
Well, what's your favorite food? And obviously it's not the same as like chicken tikka masala in London. So what's your favorite here?
Crawfish and noodle.
Oh, right.
I love going to crawfish and noodle. And if I'm here during crawfish season,
oh man,
I will be messy.
Yeah, no, I get a couple of entrepreneurs together to go out and get crawfish when it's mid-season. And I think Greentown also runs like a crawfish night, and they will fill up, 3 long tables, probably 80 people, pull out the crawfish. It will smell like crawfish for a week in there. But that's
well, I was gonna say,
awesome.
The most obvious recommendation I'd say if you're coming to Houston, right, and you want to set up an office, I think if you just go to the Ion or you go to Greentown Labs and you just take a look at the facilities available there, not only the collaboration spaces, right, which is a minimum required, but if you look at the maker space that the ION's got as well, you've got quite a lot of hardware and more hardware getting deployed into these systems. So everyone doesn't need to build their own lab. Everyone doesn't need to build their own 3D printer or buy their own 3D printer. And so I think especially for those earlier stages, that becomes increasingly valuable, and it's a low cost route to building an office, right? And building a presence.
And what are some gaps that you see in the Houston ecosystem where it's like, oh, if only we had this?
It could always do with more investors, right?
Yeah, is that,
as a startup.
But investors early stage, is that?
I can only look at it through the stages we've been through, right? We're at Series A right now, and I think that's really well represented. Series A, there's a lot of focus on that. I think that's a sweet spot for a lot of CVCs as well. I think. But there's a defensiveness as well, right? Which I've observed, which is even through the program, it's like, well, we might not be the West Coast, and I was like, okay, well, as an outsider, right, from coming at it from the European side, West Coast, Houston, whatever, I still see a ton of investment thesis that are aligned with climate tech, which are aligned with deep tech again. So for me, it's less of a comparison. It's more just about, okay, leaning in on that conviction, leaning in on the strengths that we talked about, that focus on technology, that long-term thinking, and pulling that into the funds here. Is I think more of that is better. And we'll see more and more programs like the Rice Clean Energy Accelerator, I think, grow out of it. And it's just self-fulfilling circle, right? Self-fulfilling prophecy.
Yeah. Good. Well, we're all working on it, so we'll check in a year and see what it's like. So as we think about where you guys are headed next, is there anything our audience can do to support you guys at Lena?
I would say follow us on LinkedIn. LinkedIn is the best place to get our real-time updates. We tend to showcase when we're doing things in the lab. Like last week, we installed a new robot, and I'm then the commercial guy, so I shouldn't really be down on the lab. And I think everyone sees me in the lab. And it's like I'm make believe scientist, right? But geeked out massively, so took a video of that, and just fun stuff like that. I think gives you a real sense of the DNA of Lena. And then if you're an investor who are looking in and around Series A, more than happy to get in touch with us, whether it be for this round or the next round. Just connect with me on LinkedIn, and happy to share what we're all about.
Good. And I'll have that information in the show notes for people who want to find Will. Fantastic. Well, thank you for being here.
Thank you so much for having me. I said when I got here, this is a fantastic studio. I just wish I could stay here and we can try some of your whiskey for the rest of the day. But we've got real work to do.
Yeah, I know. It's what, still Thursday morning, so maybe later.
Not in UK time, but let's take that offline.
That's good. All right. There we go.
Cheers.